Good day, everyone. This is Universal Attitude in Mathematics 1 or SAT Math 1 on class. For today's lesson, we will have variables and expression. So, what is a variable? In algebra, variables are symbols used to represent unspecified numbers or values. We also have the term algebraic expression, which is a collection of numbers, variables, operations, and grouping symbols. So what are these operations here? These are the fundamental operations in mathematics. You have addition, subtraction, multiplication, and division. And then for your grouping symbols, you have parentheses. You can also use brackets, or you can have a pair of braces, or you can have all of these grouping symbols in one algebraic expression. Now let's have some verbal phrase here, and we will have the algebraic expression of that. So you have the sum of 20 and number n. So when you say sum, that is a result when you add numbers. So you will have 20 and the number n. So actually you will just be adding 20 and the number n. So since you're getting the sum, that makes it 20 plus n. Then you have 9 more than twice the number a. Twice the number a, that is 2a. 9 more, so you're adding 9. So 2a plus 9. The number increased by 12. You have m plus 12. And then let's have some subtraction phrases here. So you have the difference between the number x and 7. When you say difference, you are actually subtracting because the difference is the result when you subtract two numbers. Then between number x and 7, so that would just be x minus 7. 3 less than a number b. Your number is b less 3, then you will have b minus 3. Then you also have the word decreased by. When you say decreased by, you are just actually subtracting it. So 3 times the number k decreased by 5, that is 3k minus 5. Another examples here that involves multiplication. So when you have 11 times z to the third power, 11 z cubed, you are just going to write it beside each other. Then you have 2/3 of a number x. 2/3, that is 2 over 3. Of means multiplication. So you have 2 over 3x. We don't use for multiplication. We don't use, x for multiplication because x is used as a variable. And then the product of -2 and a and a number n, so you will have 2n. N divided by 8, that is n over 8. This one is pretty obvious because you are dividing it. And then when you say the 15 and a number d, so you have quotient is a result when you divide numbers. So you have quotient of 15 and the number d is just equal to 15 over d. Okay, let's have some examples here. Write an algebraic expression for each verbal phrase or verbal expression. The first one, 10 less than 1/4 the cube of p. So for your solution, you have to be very careful and try to analyze each word that is used here. So you have 10 less than 1/4 the cube of p. So you're actually getting 1/4. So you have 1/4 the cube of p, that is p cube, and then 10 less, so that's minus 10. Therefore, your algebraic expression for this statement is 1/4 p cubed minus 10. Another example. You have twice the difference, x and 16. We will be very careful here. Twice the difference. What is a difference? The result when you subtract between x and 16. So in other words, you first get the difference of x and 16 before you get twice of that. So you will have x minus 16, twice that, that is 2 times. So you will have your algebraic expression is 2 times x minus 16. Another example. 4 times the sum of number and 3. What you will do here, you have to let x be your number because we do not know what the number was. So you will have 4 times the sum of a number and 3. So let x be the number. Then sum of the number and 3, you will have x plus 3. And then 4 times that, so you will have 4 times the quantity of x plus 3. So your answer for that is 4 times x plus 3. Another example. You have 4 times the number increased by 3. Now, if you notice, you might say that, oh, they're just the same as the third example. But you have to be very careful here because in this example, you have 4 times the number. So we let x be the number increased by 3. So you're actually getting 4 times the number first before you increased it by 3. So therefore, you will have 4x, that is 4 times the number x, plus 3, that is increased by 3. So therefore, your algebraic expression is 4x plus 3. While on our third example, you have 4 times the quantity of x plus 3. Then let's have simplifying algebraic expression. How to simplify algebraic expression. But before we do that, we have to learn some terms first. So the first term that we use in algebraic expression, in simplifying algebraic expression, we need to know the term. What is a term? A term is a number, a variable, or a product, or a quotient of numbers and variable. Example of a term in algebraic expression, you can have just a number, or another way of saying it, it's a constant. You can have a variable. A variable can be any letters of the alphabet, and then you can have the product of a variable and a constant. So that is, you have 7a. You can also have both constant, that is b times b, which is b cubed, that is also a term. And then you can also have a product, a quotient, and one example of this, of both a constant and a variable or variables. You have 3 over 4, that is your number. You have m cubed and n, so you have two variables here. That can also be, this one is also a term. Then you have coefficient. Oh, like term first. Like terms contain identical variables. So you have, for example, you have this expression 5x squared minus 3x squared plus 3x. The term 5x squared and negative 3x squared are like terms. Why? Because the variable part, which is your x squared, you have here x squared as well, are identical. When you say identical, they must have the same exponents. Okay, you have squared, and you also have x squared here, so they're the same. Unlike 3x here, we do have the same variables, but we don't have the same exponent, so 3x cannot be like terms with other terms here, 5x squared and 3x squared. So they can only be like terms if the variables have the same exponents. Okay. Now let's have another term, the coefficient. Coefficient of a term is a number that multiplies the variable. So examples of coefficient, so you have a term 8x squared y. So the coefficient of that is the number that multiplies the variable. So you'll have 8. And then another example, you have 4m over 5. The coefficient is 4 over 5. Now you might say, why not 4? Because 4 over 5 is a fractional coefficient. Another way of writing 4m over 5 is 4 over 5m. They're just the same. And then we have properties of real numbers that we use in simplifying algebraic expressions. So the first property is commutative property. What is commutative property? For any real number, a and b, a plus b is just equal to b plus a, or in multiplication, you have a times b is equal to b times a. What does that mean? That the order of the numbers here does not affect the answer. So if you add, for example, 3 plus 5, that is just the same as 5 plus 3. The result will not change. And then you have 3 times 5 is just equal to 5 times 3. Whatever the order is, you don't worry because the answer are just the same. Then you have associative property. What is associative property? Associative property, for any real number, a, b, and c, a plus b we group together, plus c is just the same as, or it's just equal to, when you group b and c and then add that to a. So you have a, the quantity of a plus b plus c is equal to a plus the quantity of b plus c. Same through when you multiply. When you group together A, B, and multiply that to C, and then it's just the same as when you group BC and multiply that to A. So you have here example. 2 plus 3 equals 5 plus 5 is just equal to 2 plus 3 plus 5. So when you multiply, the same way happens. And then you have distributive property. For any real number A, B, and C, if you are going to distribute this, AB plus AC. So you are actually distributing A to B and then A to C. That's why you have AB plus AC. Same through here. If you subtract B and C, you have here A times B is just equal to A times B minus AC. So you distribute A to B and then A to C. That is what it meant by distributive. From the word distribute, you are actually distributing the first component here. Example, 2 times 3 plus 5. So it's just equal to 2 times 3 plus 2 times 5. Or in this case here, you have 2 times 3 is equal to 2 times 3 minus 2 times 5. Okay, so you can follow that. And then let's simplify some of this expression here. Let's do letter A. You have here 1/3 m minus 4n plus 2 and 2/3 m is equal to, we combine like terms and we have m here for both the first and the third terms, so we can combine them together. How to combine them? We add their coefficients. So you have 1/3 plus 2 and 2/3 m, so that is equal to 3m. And then just carry this 4n down. So you will have to simplify that. You have 3m minus 4n. The letter B, 4x cubed minus 3 times x cubed plus 2x is equal to 4x cubed. You distribute negative 3 here to x cubed and 2x. So you will have 3 times the quantity of x cubed minus 3 times 2x. That is using distributive property. And then after that, we have to multiply this to, so you'll have 3x cubed. Negative 3 times 2x gives you 6x. You just multiply. And then since 4x cubed and 3x cubed are like terms, then we can combine. So your final answer will be x cubed minus 6x. You cannot combine anymore x cubed and 6x because they are not like terms. Number 3, or the third example, letter C. You have A times the quantity of 2 minus B minus the quantity 2 times the quantity of A minus B. Distributive property. So you are distributing A to 2 minus B. That is why you have here 2A minus AB. Then you distribute negative 2 to A minus B. That's why you have negative 2A plus 2B. We use distributive property. And then after that, we can use your commutative property, So you can bring together 2A and negative 2A. Then you will have minus AB plus 2B. Now, in this case, if you combine terms, negative 2a minus 2a, that makes this whole thing equal to 0. So what remains is you will have negative ab plus 2b. Then let's have some exercises here. I want you to answer this. Try to write an algebraic expression for each verbal phrase here. This will serve as your homework for this week. And then exercise B, simplify the following algebraic expressions. So you use all the properties to simplify these algebraic expressions. This is your homework for this week, and this should be submitted to me when you come to school in July. Thank you for listening. Thank you for watching my video, and see you in the next lesson.